Welcome back, everybody, to the June version of the Ceph Developer Monthly. We are on an EMEA-friendly time. Next week we'll have, or next month we will have the APAC-friendly time. So it looks like we have about 6 or 7 items to go over. So I guess we'll go ahead and jump right in there. And if anyone has anything to add, just as a reminder, that this agenda is built organically on the Ceph wiki, which is part of the tracker. I will put a link in the chat here to the doc that I am working from. So if, as we're discussing things, anyone has any other work that is ongoing or they would like to discuss, go ahead and just add it to the bottom of that doc. So it looks like the first thing, we'll just start top to bottom. Make sure that we have, yes, Jan is here. librvd persistent cache updates. Did you want to give a bit of a summary of that, and then we can tear into it?
Yeah, thanks, Patrick. I'm going to share my screen here.
Here it comes. All right, we see your browser, and there's the PowerPoint. You should be good.
Okay, so I'd like to give you guys a quick update for the RBD persistent cache. So here's our current status for the PR. Basically, it's based on Jason's sketch, Jason's web branch, and I added some comments into that branch. Basically, it contains a generic file-based caching framework with write-through, both write-through and write-back support. Currently, the key components for the caching logic are journal store, which will record all write-back events with an ordered sequence, and also image store, which will store all the cache events. And also a meta store, which will persistent to the cache mapping. So here's a basic I/O flow for the write-through model. Basically, it will issue a write request to the file image cache, and also to the Redis tier, which is quite clear. And this is for the I/O flow for the write-back mode. It's a bit complicated as there's a journal store involved. The first, say there's a request from application layer, it will be enqueued into op work queue inside librvd first, and then it will be popped out and then go to journal store. And journal store would record this request to a journal file, and then there will be 2 requests which goes to image store and also meta store separately. And after the request has been well,
we can hear you. As I can.
Okay. So after the request has been persistent to the journal store. There will be ACK to the clients, and also there will be corresponding write-back request enqueued to the op work queue, and later, sometime a few seconds later, maybe this write-back request will be executed, and the data will be flushed to the Redis tier. So this is the basic workflow for write-back mode. And I've just got some early performance on the current branch. The performance looks not so good. Oh, by the way, this is a 2-node setup with 4 OSD on each server. And the baseline is without caching. For 4K random write, we can get 2,600 ALPS with rest-through mode. And the IOPS dropped a bit, but it still can go to 2,000. But with write-back mode, it just suddenly drops to 1,000. So this is kind of, I guess there's still some bugs inside the branch, which I need to dig more of this. Okay, so here's some next steps currently in our plan. So until last week or 2 weeks ago, we had a sync up with Jason, and Jason pointed out there will be we have to respect the write barrier from application layer. Currently, in the pull request, write barrier actually are ignored simply. So we thought about this, and there might be 2 possible ways for write barrier support. The first one is we call write back flush, which means if there's a write barrier request, first all the in-flight and dirty data will be persistent to local SSD, and also there will be a corresponding flush request to the Redis tier. That means all the data will be persistent to local SSD and also persistent to Redis tier. So that in this way we can get a clean and a safe write back on the write barrier request. And the second one is we have a write back persistent, which means let me go to this page. Okay, so this page we have a detailed explanation on the write back flush. So this is on a write back flush. We can guarantee all the data be consistent and durable on a destructive failure, but also friendly for sync heavy workloads. And on the write back persistent page, it will be a bit simpler for the write barrier request. Firstly, all the in-flight requests and dirty data will be persistent to local SSD also, and instead of flushing those requests to Redis tier, we just persistent the dirty mapping to local SSD also. So we can save some writes to the Redis tier. And also we can reduce the latency on the sync requests. And when the dirty ratio reaches some threshold or interval time expires, we then start the write back request. And also on our recovery, dirty data and cache mapping will be read from local SSD. So we thought this write back persistent strategy might be might have a higher performance for those sync heavy workloads. Okay, so next one is we're also trying to build a smarter policy for the write back support. For example, we can instead of using a time-based flush, which is implemented in the current PR, we can use some smarter flush or evict policy, like based on some dirty ratio threshold or max interval time, etc. So there are also several other to-dos for the current PR, like the unit tests and scatter gather support, and also the some in-memory caching support. But this, I'm still trying to learn more about these modules. We'll do that a bit later. Okay, so this is more of the updates from here. Maybe some questions.
Yeah, so this is Jason. I mean, I know we talked, several times. Still would like to see this get kind of refocused. Don't worry about the write-through case, because so the selling point here, right, would be eliminating tail latencies, just because the network hop. So if you go right through, that's you're just adding overhead. So for the write back case, and if we're only supporting and this is an optimization for the write back case, we just basically need to stream the data as the writes as they come in to, append operations to like a local file, and then we just have a periodic process that, can coalesce events and submit those to the OSDs as needed in the background. So I think the write back picture is still too complicated for what it really needs to do, because it really should just be streaming the events to a local journal file, and then your write back thread periodically is pruning off the back end of that file, potentially one or more files or whatever. If you consider it kind of like a ring buffer, but you implement a true ring buffer, or you just use n number of files where a certain file can only grow so big, and then you just have you're writing, and then if you get so big, you open up a new file and start writing to that file where your write back process or thread is just sucking, chewing events off the tail of the journal. The image store or whatever, that's kind of like for the read case, and that I think that is a different use case. That's the generic use case we've talked about for that could be applied to RGW or for the immutable RBD parent images for just caching reads. But for the journal stuff, for the just eliminating write tail latencies, that I think is just a straight and simple journal, and with write back from that journal, and not to worry about the write through case if you're enabling this feature, because this is something you're opting into. This is not like going to be the standard practice for RBD.
Okay, I see. So, Jason, I have a question on the write-through mode spot. Actually, in write-through mode, we don't need the journal store, right? We actually can just write directly to the image store and maybe the meta store directly.
Well, so in this case, the write-through mode gets you nothing, right? Because you're going to either have to do double the work, or if you see you get a flush operation, you're going to have to track what blocks or extents within that image store are dirty, and you need to ship them all off to the OSD, right?
Yeah.
But I mean, if you're true write-through mode, where you're writing to the local cache and also sending to the OSDs, and you don't ACK the write until the OSDs and the local disk have safely committed that to disk on both sides, what does that buy you? You've just done double the work, and you still have the network latency in the picture.
Okay, I see. Okay. So actually, in the current PR, I'm using the write-through as the default mode to otherwise some unit tests may be failing. So I agree, write-through mode may be more common case for production environment.
Well, I think the write-through mode isn't. No one would use it, right? Because otherwise they would just not use the cache.
Well, I mean, eventually there will be a working read cache, and once you have a working read cache, then, and if you didn't want to like sacrifice the timeliness or whatever, the durability for and do write back, then write through obviously makes sense. But until we have a robust read cache in place, then it doesn't make sense.
And if read cache, I mean, I think the read cache are really only going to get the best performance bangs. I mean, so your operating system on top of RBD already has its page cache, so it'd really only be like the warm up of a new OS that would actually benefit from the read cache, right?
Yeah. Yep. I think the right one is going to be sort of it's going to be simpler to implement, and it's going to be a bigger bang for your buck with larger user impact or whatever. Is my impression, but.
I mean, yeah, it definitely seems like that's the use case that people are interested about, of like, how do I just reduce my write latencies? And if you're just trying to reduce your write latencies and you're trying to do it in a safe and consistent data way, you just blast it to a journal and
stream it out
to the OSD safely, respecting the write barriers, your flush requests.
Okay, I see. Well, Jason, do you have more comments for the in-memory cache support? I mean, for the current architecture, the image cache is actually above the existing in-memory cache. It's kind of awkward.
Yeah, and again, so as I mentioned before, I think just for your initial work, you can just disable the in-memory cache, because again, it doesn't buy you anything. If I'm saying I want to write back, and I'm trying to write it to the local SSD, the in-memory cache buys you nothing.
Yeah.
The only thing it buys you on writes is that it can coalesce the writes, but your SSD cache should be also coalescing the writes to the same object. And on reads, it can help support read ahead and things like that. But the operating system itself, once it boots up, is also doing read ahead. So that's why it's not like a big bang. I don't think it's worth it to focus on it right now and just say, if you're going to turn this on for this initial prototyping and effort, let's just focus on it's a single use. Like if it's on, and you're not using the in-memory cache at the same time. Eventually, yeah, we might again circle the wagons back and like make everything pretty and hooked up. But I think just for your initial focus, I'd say assume the in-memory cache is off, or explicitly turn it off if during your testing when you're using the SSD-backed cache.
Okay. I see. Well,
I mean,
that's
sorry.
Is that everything for this one, or we have more to discuss?
Yeah, I think that's all.
Okay, great. Thanks, Yun. That's great to see that level of depth on a CDM call. So good. The next one we have up is the pool tags metadata. I see it's Sage and Jason. Jason, would you want to summarize that one?
I'll work with Sage on this one. I just signed up for it this morning.
Yeah. Yeah. So this is all. The next several items here are part of a broader discussion that we're having on how to improve overall Ceph usability, things that users are frequently confused about when they're setting up the cluster, or just like don't make sense and have been sort of inherited over time, or just whatever we can think of that is going to make things easier to use, more intuitive, and so on. And this particular one was motivated because Jason was adding something to the new Ceph dashboard, which is sort of a webby version of Ceph-S. It already has some stuff there that tells you about your file systems. He was adding stuff about block, but it was unclear how to identify which pools were RBD pools and which pools were not, without going and looking in the pools and looking every time there's like a map update or whatever. There's no sort of easy way to identify those. And so the sort of intuitive solution suggestion was to add a simple tagging facility so you can associate metadata with pools. And so you can say, for example, this particular pool is an RBD pool, this particular pool is a Ceph pool, and potentially other things too. Like in the Rados Gateway case, you're going to have multiple zones, so you can tag the pool with which zone it belongs to, and so on. So there's a Trello card associated with this. Doesn't really have any detail yet. I just wanted to make sure raise this with a somewhat broader audience, make sure it kind of makes sense to people. And I just closed my tab. So find that again. Yeah, I had a couple quick things to mention while we're talking about this specifically. One is that there is already a piece in the PG Pools T structure that lets you associate other sort of key value type properties to it, but they're sort of meant to be currently pool properties based on how their things are being used. So we started adding all these fields to the PG Pool T structure for cache tiering, and it just started to get crazy. And a lot of these are optional. And so there's this thing in here called, I'm just giving the code here to try to find it. It's called Pool Ops T. Let me paste this in the chat here. It's here. And Pool Ops T is here. And so these are a bunch of things like setting what compression algorithm you want to use for BlueStore for the object stored in this pool, what your checksum chunk size is, blah, blah, blah. And so we already have this sort of key value property value type mechanism. And the sort of initial proposal based on what we were seeing was to simply add like a map string to string to the pool with sort of like high level more user visible metadata, as opposed to like the in the weeds tunables pool properties. But I'm not certain that distinction makes sense. I just wanted to check.
Personally, I didn't realize that pool absentees in there. But to me, like the idea of like having a free-form string that was like the owner is RBD just seemed kind of like kludgy to me. So if there's already something there that we could just extend that says,
Pool
pool
type.
owner, pool type, RGD, FS, RGW, and then in terms of RGW, if they wanted to have like a special key they could put on it or whatever, for zones or something like that, or if the file system wanted to have it for file system A, file system B, file system C, or however those are labeled if you're supporting multiple file systems in different pools. Seems cleaner to me.
Yeah. So I think that the difference is that this here and all the existing pools in PG Pool T are like strictly typed and structured, and they control specifically how Rados internally behaves. And in my mind, the original thought was to add sort of a user-facing tagging mechanism, so you can say, oh, this is my pool for X and this is my pool for Y. I'm not sure if that makes sense.
You're thinking more like an administrator-like way to annotate properties.
Yeah.
Kind of like RBD,
Yeah.
we have image metadata where you can just do arbitrary key value pairs.
Right. That's sort of what I was thinking.
But that's IT, like administrator level stuff versus.
Yeah, or just the consumer of the pool, right? So if you think of RBD as the thing that's consuming Rados, then it sort of has its arbitrary stuff, and RGW can tag it however it wants.
So I think we should, for things like RBD and RGW, they shouldn't have like strongly typed stuff in the OSD map structure. If something's going to be consumed by external tools, where things like RBD and RGW are external to Rados, we should make it freeform enough that anybody using Rados could use it for whatever they needed to use it for. That might still, but I think there's still an argument that the protocol field, or for who is using this pool, that key, which we're going to be relying on being set, being a certain magic string anyway, maybe that one should be strongly typed, so that we always know like what key that's going to be.
Like a separate field, like owner or type.
Yeah, but I'm not sure if it should be a list or just a single one.
Yeah. So it's going to be a string, right? It's not going to be like an enum of RBD, RGW, whatever, because this is any Librados user.
Or an enum value of external.
Yeah, right. Which means it seems like it's either just like we have a map of string to string, which is arbitrary metadata, and then we have another string that's just like owner. Or we just, by convention, say that particular key, like owner equals foo, in that other map. I guess I'm not sure. I don't know. I can't decide.
Well, John's saying we want this to be general enough for anyone to use, which makes sense, but also it needs to be formalized enough that stuff like the manager can count on it if we're going to start doing different displays based off of what's there. And once we have it, we maybe not, but I feel like once we have something like that, we actually want our tools to start paying attention to it so we can go, hey, you're like trying to invoke the RBD tool against a file system command. And at that point, like, it needs to be pretty strongly typed because.
So I would claim that whichever Librados consumer it is only needs to know their own magic value, right? So the key needs to be well defined so that
exactly, yeah.
I can go look for that key and say, is someone else already using it? But like the actual string that says RBD or RGW or whatever, that doesn't need to be centrally defined. We don't want to have a registry inside the OSD map that lists possible values because it could be anything.
So that sounds to me like we want two new fields for PG Pool T. One is owner or type. I think we can't use type because type is already the pool, PG pool type or whatever, like replicated URC. And then we want the map of strings to string. That's just, and then when you create a pool, you specify the quote unquote type owner as a required field. So when you create the pool, you say this is an RBD type pool.
Can we
and
call
then,
it application instead of owner? Because owner sounds like it's going to be like an authentication identity or something.
Yeah, sure. Yeah. Okay. So I didn't create a pad for this, but we'll do that right now. Pool metadata.
I mean, does that not fit into the pool ops thing? Like, it doesn't look like. I mean, it's got
the pool. The pool metadata is hard coded what keys are allowed, and I think the type of their values, although I'm not sure. Actually, the type might not be associated with the key, but they're hard coded key names.
Yeah, so like,
which means that a liberator's user can't do something else.
Well, but I mean, if the key name is application and the value is a string that says what the application is, that's what we want.
Yeah, I guess so. Yeah, but in this case, we want to make this a required field. And the properties, the reason why we added this property is because we didn't want to keep adding all these rarely used fields to PGPool2 that was all. So string application, and then map of string to string of just like metadata, I guess, that we're looking at. And then
I'm fine with that. How does PGPool create?
If it's just a string for the application, do we really want a separate metadata key value mapping?
Well, that's for the arbitrary stuff like the RGW zone XYZ.
Which zone it belongs to. I'm a Rados pool backing a backup application, which appliance is consuming it. I don't know, whatever.
Why is it better to store this in a special pool metadata field rather than an object in the pool?
Because you want to be able to do your control plane stuff, whether the data is accessible or not.
Yeah. So that the problem in that Jason tripped over was he wants to list the pools that are RBD, and he doesn't want to have to go do IO to the pool to is there an RBD directory object there now? What about now?
If John just put the caching thing in, it would just work.
Adding something of arbitrary size to the map.
That's true. We should have a sanity thing that prevents people putting a bajillion keys in there, because some idiot will try and do that.
Yeah. Or 4 gigabyte value.
Yeah.
Max value size. The max keys would be 64. Max size would be 120 bytes or something. I don't know. Keep these small.
This is the kind of thing we would use from the Manila driver as well. If it was creating pools, it would put a tag on to say which Manila share the pool belonged to and that kind of thing.
And you said several times, Sage, that you want this to be mandatory, but in that case, we need an upgrade path, and I have no idea how we might do that.
So
mandatory when you create it, probably.
Yeah.
Right.
I'm saying a mandatory argument for creating new pools, because yeah.
Isn't there already hey, I'm in the middle of upgrading process, or wasn't there a new Ceph command for that, or no? It was just auto-detected.
Yeah, I mean, so for a bunch of these, we can set them automatically, and that's probably going to cover 80% of clusters, because if the pool ID is 0 and it's called RBD, then it's the RBD pool. If there's a CephFS FS map that refers to it, it's an FS pool. So we can just set those. If it's, we can probably write some simple heuristic to identify the RGB.
Can have all modules just check it. All modules can just check it on initialization and see are they empty. If they are, then just set it, one time.
Yeah. Right.
If you have the permissions.
The code that consumes it, if the RBD client is checking it's talking to an RBD pool, then the client will need to also accept the field being set to none for legacy clusters.
Yeah. Yeah.
No, I was thinking for the RBD, you would basically just restrict the new operations of creating new images or whatever. It wouldn't stop you from opening, existing stuff.
All right. Okay. Yeah.
That'd be the backwards compatibility path for that. And we just have to have the upgrade note of saying, if we can't determine these heuristics, it's like upgrade the mons, set this thing, and then proceed to upgrade all the clients, because otherwise, your Cinder won't be able to create new images if you didn't, tag the pool appropriately.
And the mon can issue a warning if pools are untagged. So during the upgrade, all the stuff that can't automatically be labeled. And then we'd have Ceph OSD pool application, pool name, pool, like that. Okay.
So I think the last question we had was, are we okay with breaking the compatibility on the OSD pool create command to add this field?
Yep.
Well, so if you do it with a -- application equals whatever, if they don't provide it, you can at least do a deprecation warning saying, hey, this is now required, but we'll allow you to proceed. So you're not breaking CLIs, but you're giving people like one release or whatever to get used to it. Or you just rip the Band-Aid and
the Ceph CLI command parsing isn't flexible enough to give you sort of these optional named arguments. Ironically, given that we wrote it that way so that we could put it all in JSON. But yeah, it doesn't let you do that, unfortunately.
Maybe we can fix that.
We can make optional arguments that go at the end, but it doesn't let you do optional arguments that are like -- foo space foo that are named.
Oh, I see.
That's just not how the parser works.
-- equals foo.
If
is that something we want to fix or don't want to fix?
Things that are, I think that the real question is like, if old tools are using the old pool command and they don't label their pools with the application, if they're quote unquote broken, then we should make them break at pool create and not later when like some random functionality fails to work, right? So I think the question is like, are they broken by not setting application field? And are they that broken? I tend to lean towards just breaking those types of applications because they're going to be validated on Luminous anyway, and these are like easy things to fix. And if they stay broken and then like 3 months in they realize that the dashboard doesn't show RBD pools for some reason, that's hard to notice and it's going to waste more time. So,
but will the dashboards show other pools and say that they're untagged or something like that, so that
yeah, I mean, we can make the health warning will be there, but I think it'll be more confusing, and that's something that the user is going to hit. Whereas the things that are have scripted creating pools are more likely to be developers who are working on the integration for managing a Ceph cluster.
We've told people a million times that the command line isn't a long-term stable API. This is a great opportunity to
remind them.
Remind them, yeah.
Yeah. That works for me.
So go for breaking.
Great. So it'd be like pool name and then application and then pgnum or something. And then all the optional stuff. Blah, blah, whatever. Go for broke.
Well,
would be
the
nice if
problem
the active
with
parts
breaking it
did
is
support things. Sorry. Go ahead, Yuta.
yeah, the problem that I see with breaking is that you're kind of fixing one usability issue with introducing usability issue where users are suddenly hitting this issue, that where the command line is more complicated now and they need to learn something new that they didn't know before, or that things are kind of, suddenly not working again. And so, I'm not sure, maybe we can have some other solution that wouldn't require breaking it, like doing something automatically somewhere, like an upgrade path would be fine. But
So I
Yeah,
think this is going to be a recurring situation where we have people who have written their own scripts and automation around our stuff because our stuff was too hard to use on its own. And as we sort of change the way we define things to make things more usable, it's gonna cause some breakage. I think for human beings using the tools directly, we can make it reasonable. We can make it friendly enough that it's not a usability issue. It's just a change, right? So if they omit the field, it needs to at least tell them that.
Right. But you run a command to create a pool, and now it tells you, hey, you're missing the application field, and like, what the hell? What's an application field? What do I need to put in here? And do I need to go to the documentation now and read another paragraph? And where's the documentation? So you're kind of adding a complexity, for someone who's not a savvy user of the system that now need to learn new stuff that might not be necessarily for their specific use.
So we're talking about people who are accustomed to. We're not talking about people who are like new to Ceph. It doesn't make it harder to work out for people who are new to Ceph. It makes it annoying for people who already had memorized these command lines.
It might be someone who's new to Ceph and found, happened to stumble on, read the wrong doc. Okay, the doc that they saw Google. Right?
Well, the alternative is that it's not a required field, which means we don't know, and then the tools will not be able to conclude anything. Will like issue a health warning, and so they create a pool, and suddenly there's a warning that says health warning. Your cluster has a pool that does not have an application labeled for it, or something. Right? Like at some point we need to
or the tools
be able to
themselves
move.
Like if it's just the manager dashboard, that can say, hey, you have unlabeled pools. Tell me what to call them.
It's not just that. It says like this is preventing people from accidentally sharing pools between RBD and FFS, for example. Like it's putting some guardrails on the system. It's
Yeah, but I mean, at that point, you can just make sure it's not the wrong thing. We don't have to check it's the right thing, and that's not quite as strong, but it's pretty close.
So I think the strongest argument for this is that anybody today who tries to write a web interface to Ceph that lets you browse your RBD images has this kind of, there is no good way to do it, right? And the only way to create a good way to do it is to make this change. And the only way to make sure that the people who write interfaces like this can use it is to make sure that it's always set, because otherwise, they're going to have like some old setup script that has created a Luminous cluster but not bothered setting any application fields. And when they open their GUI, they're just going to see a list of all their pools when they go into their RBD section. And, we have to be able to change things.
You need to set these values, and then the dashboard will be useful. Like
right, but that comes back to what Yehuda was saying. That at that point, somebody is then having to go to and like learn this special command they have to run, and I think it's okay for someone to have to go and learn how the latest version of the command line works when they make a major upgrade from one LTS stream to another. But I don't think it's okay for our latest code to ship in a form that isn't sort of robust within itself.
That still leads people down an error-prone path. Yeah.
Well, so speaking of error-prone paths, so we give this. They're doing a Ceph OSD pool create, and they provide a freeform string. I mean, how are they going to know that they have to type in RBD or CephFS or FS or RGW? Maybe it's up to the tool.
The help string will have EG, comma, RBD, RGW, CephFS. And when they omit it, it will say the same thing.
So
I'm just wondering. So I'm not. I know CephFS has a way to initialize a new file system. Does RGW have a way to initialize a new file system? Because then it's just RBD that we could just have a RBD init, and then that just does the monitor command to set it. And we can add it.
Yes. That's how all this should work. There should be a single command for CephFS that creates a file system and the pools underneath it, and there should be a single command for setting up RBD. The issue with doing both of those things is carrying around the PG num field everywhere. But yeah, I think in the short run we have eventually, right? So in the short run we have the help text that says EG RBD, and let's face it, most people most of the time when they want to know how to do something like this, they're consulting, the web or the documentation. They're not knowing the command off the top of their head anyway. We have to accept that in the long run, this is still quite the OSD pool create command is still quite a low level thing, and there should be things on top of it.
Well, so I'm getting at if our end state is eventually going to migrate towards RBD init or something like that, why not? Yeah, right now you have to do the OSD create pool to do it correctly, but in the short term you also just have to do the RBD init or whatever, to.
Well, I mean, you could add an RBD create -pool command that does it also. Yeah. RGW, for example, already creates its own pools, so it would set the application fields. We can make that change in tree.
So CephFS has one, RGW has one, RBD is the odd man out.
CephFS will have one soon.
Yeah. Well, it's got that Ceph command that initializes, right? So it's not creating the pools, but
it needs a different syntax because it needs to be able to take a PG num argument.
Well, but even though it doesn't, itself, it can add the labeling. Like we can label it CephFS once we put it in an MDS map.
Yeah.
I guess my thing is that if we're not going to validate the input ourselves, which we can't, because there are some people who aren't using our systems, they're using raw rados, then not super useful because they can get it wrong.
So this was actually my original proposal, was to not touch create, but just have a command you run after that. That's like cephosd label tag bool. But it means that there's yet another step that you have to follow, and the question was whether not actually taking that step was a valid use case or user. If you don't do step 2, you've done it wrong, then it shouldn't be a separate step. It should be the same as the first step.
Well, so
but I would argue that with the set command for setting the tag, still skip that step and let the individual known
tools can do it.
Product do it, because they have to put their magic string in, right? Instead of having to type this exact string.
So then the RBD CLI will say this pool isn't labeled for RBD use, but it can't set the label unless it has a capability that can do it. I guess most of the time it will.
If you're running the CLI, you probably already do, because everyone seems to run with admin. But yeah, Cinder probably won't. Yeah. That's why you don't want the Cinder to automatically do it. But if everything's failing, you get the nice helpful RBD CLI that says, "Hey, this is not an initialized pool. Please run this command." You have a path forward. It trains them, and then we can also update our quick start to say, "Do this," just like CephFS already has the initialize the.
And I mean, you can just do it automatically if there's not already a tag set.
Yeah.
Right.
If you have permission.
And we shouldn't fail the commands. We shouldn't. shouldn't fail CephFS or something just because it doesn't have a tag. Just like can be a nice warning or something, but you know, as long as it's not required for running it, right?
Or it could. Well, I guess it's the question of how.
Well, so
how
Luminous,
many
it could be a warning,
states we want to concerned about.
and
We don't need to worry about CephFS. We can, on the upgrade, say these are all the pools that are in MDS maps. Tag them. When you add one to the MDS map, we can tag it, so it knows. That's deterministic.
And FS new can just label as when you create the FS, it'll label it then.
Yeah.
RBD can error out or it can warn.
We can look for the RBD directory object and then just test it to tag if it's already there.
If it sees it there, then it'll set it.
Otherwise, write a warning.
What if it's there but it has the wrong value?
Then it should error out. I think that's the point, right? If you try to create an RBD pool in the CephFS pool, RBD image in the CephFS pool, you should get an error.
What if people were abusing the same pool already, running multiple applications on the same pool, and everything was working for them now because there wasn't any naming collision, but now they wanna upgrade?
We could.
So at that point, if we want to actually make that work, then we should make it work properly, and the application field should be a list rather than just one string.
Like a tag. Like a set of strings.
do we want to make it work? I'm not sure.
I'm not sure.
Do we want people to use the same? Yeah.
I mean, I think in general, I don't like people doing it, but especially when we're moving in the direction, at least with CephFS, of getting people to put everything in a Rados namespace anyway, and at the point that we're letting people put multiple file systems, letting people have multiple file systems use the same pool, which is fine because they're using different Rados namespaces. It seems a little strong to also tell people that they can't put RBD images under a namespace in that pool.
Yeah, I kind of agree with that.
Right. Yeah, also, right, we do support multiple namespaces in RGW, and part of it is like you want to specify that the pool is for specific use. I'm talking now about the key value thing, but the pool might have multiple uses. Like it could be for logs, it could be metadata. My question is whether a key value metadata for the pool itself is enough, or do we want it to be like per namespace? Maybe. Not sure. Probably not.
Yeah, it's almost like you want a registry of namespaces.
Well, I mean, we could have a. Is this what people are already saying, that we would have a metadata a metadata map for each protocol, right? So you'd have the list of protocols that are enabled, which would usually only be one, and then this flexible metadata map would belong to that protocol. That seems flexible enough for what we want. I'm not sure exactly how we would. I think once we allow multiple protocols per pool, then all of the things like FSNU and whatever that want to do the check that someone else isn't already using the pool would have to have obviously like an override flag that said, or it could be that the way you override it is to manually go and do Ceph OSD pool enable application CephFS, and then the FSNU would work even if it was also configured for RBD. Maybe. It's getting more complicated, isn't it?
Yeah. I mean, it feels like the simplest generalization here is that change from having an application label and metadata to having a map of application to metadata for that application.
But at the point you have a map or a list, you have to accept the case where there are no items in it, really. And so we do come back to making it optional to set the application.
Yeah. I mean, Jason seems fine with that. Yehuda seems fine with that. In the CephFS case, we can do it at FS new time, right? That it would add its metadata label. It doesn't really prevent you from having two applications that are going to conflict, right?
That has to be up to I think the application itself has to be, it's up to it whether it's going to try and coexist or not.
Maybe one of the required fields there would be, other than application, also namespace, which marks which namespace the application is using.
I'm a little bit hesitant to codify namespaces here because we made the decision that namespaces were unbounded, just like objects, in the way they're implemented. And if we sort of do anything here that suggests that every namespace has to be identified here, then that is sort of misleading. But you could have an application, for example, if CephFS puts in its metadata, it could have keys and values that report which namespaces it's using in its own sort of special way.
Wow, that's going to quickly grow without bounds, right? In terms of you're trying to limit the number of keys to 64 or something like that.
You could want it to.
We're going to keep wanting more metadata about this kind of thing, and we might not want to be storing all of this in the OSD map, or we might want a separate database for this kind of thing.
I think we should say what the application. I think the IDs should be for the application to declare that it's using the pool and put any unique identifiers on there, like zone or Manila share or whatever, but it should be identifiers and not describing what it's doing within the pool. So namespaces, I think namespaces have to be out. I mean, even in the relatively simple CephFS case, users are allowed to set layouts on files that point to other OSD namespaces.
So another way to say this might be that this is intended for declarations that are sufficient to ensure that we're sharing the pool properly and nothing else, or not sharing the pool properly, I guess.
Yes, and if the way you share the pool is dependent on namespaces, then that is within the pool. It's not, there's nothing at the OSD map level that can enforce or say anything about namespaces anyway.
Maybe if the use of namespaces is unbounded, then you can put like a wildcard or something like that to specify that that specific application can use all the namespaces. Whereas, for example, ArchW has a set of a restricted number of namespaces that it's going to use.
I think this just needs to be a tag saying this application declares it's part of this pool, and if there are multiple applications on a pool, then the admin's responsible for making sure they play nicely together, because we can't do it arbitrarily. Like we can tell people we know that RVD and CephFS play nicely together, but that's not actually true, because CephFS is going to get repair tools will get confused about RVD stuff in their pools, right? Yeah. So
I think our default everywhere should be to refuse to share pools. And I think that to share pools, you should have to run a different command of some kind, whether that's like a -- force somewhere, or whether it's an explicit enable application command. But at the point someone's done that, I don't think we can take responsibility for deconflicting them.
Yeah, so we just need to make sure that when our tools run, that it's labeled for that tool to run, and otherwise it doesn't care.
So if we go with this route where it's application keyed to its metadata, then there's no sort of atomic claiming the pool step. And I'm wondering if we should worry about that. Like this OSD pool metadata set just sort of grew an argument that specifies which application you're setting it for, but it won't like fail if RBD is already using the pool.
Is that a problem?
Is that a problem? I mean, you can then see it, but yeah, I don't know if it's a problem or not. I'm just pointing it out.
It can refuse to override and only be additive. So like you can say you wanted to set it to Ceph, but it's already labeled RBD. Do you mean to set Ceph RBD?
Well, we've gotten rid of the application field, so there's no single thing that you're setting. Like we've made it so it's
a map of maps.
Yeah, exactly. Yeah.
Yeah, but you can see that the it's not empty, right? You know.
Yeah, if you go like OSD pool metadata or pool LS detail or whatever, let's show it all. I mean, we have a Ceph OSD pool LS detail that like just dumps all the crap about pools. It feels like it's a little bit more. Maybe pool LS. No, but that's meant to be consumed by. I don't know. I wonder if there's like a new command that we want to see.
I wonder if we should have in addition to the metadata set, metadata RM, if we should have a command that says what it does, like it should be called enable application or set application or something like that, that just creates the root of the, just creates the field with an empty metadata name.
Application.
Yeah, because that's actually.
I think that metadata create is not like a descriptive piece of English for what we're doing. What we're doing is saying enable the use of RBD, right? Or enable the use of whatever.
Yeah, because do we actually have any stuff we want the users to set for our applications other than RBD, Ceph?
Yeah, so like setting the metadata is like a super advanced under the covers thing, yeah, compared with saying which application you want to use.
Yeah. And then those applications can fail.
Application enable.
Yeah, and those application enable commands can fail by default if there's already one set.
Yeah.
I'm not sure if we want to make them force it to enable overwrites, or if we want to make it like be a string, so they have to specify all of the applications that are enabled in every command.
Well, again, for the set application, that's going to be advanced person's going to be doing that, right? Because again, it's to have someone know that they have to put in RBD or versus capital RBD versus Rados block device or whatever, or just block. I mean, yeah, under the covers, the RBD CLI can issue the mon command or whatever to do it. But if you're using that CLI, I mean, that seems like
we have we've gone from a required argument for pool create to like multiple steps you have to do: create the pool, enable application, and then set some metadata about it. Although maybe you don't have, most of the time you actually won't set anything.
I think with the adding the fields to things, I'm not quite clear whether it's right that we should actually add them during things like fsnew, or whether really it should be that the user should be thinking about what protocol it's for when they create the pool, and fsnew consumes pools that were created for it, rather than the other way around. Because if you don't have fsnew automatically adding it, then the application enable thing does become more of like a first class.
But where do you see the end state of this being, that there's always going to be a pool create, or is there eventually the end state going to be that I say, I just want a new file system, I want a new RBD, so use the RBD CLI to do RBD things, use the RGW CLI to create an RGW pool? If that's the end state, why would we add this temporary intermediate step that we then yank, when we can say like, oh, now we handle PG num so that we apply the thing?
I think in many cases people are gonna be sharing, like in the case of Ceph, for example, having one metadata pool that I share between multiple file systems is going to be a pretty normal thing to do. And also having that metadata pool be on SSDs is going to be a pretty normal thing to do. So it feels very natural to me that at the point you were creating that pool, you were gonna, when you create the pool that it's for Ceph, right?
But it seems like the end state might not be you creating the pool directly, like Jason's saying. It might be a higher level command in Ceph, or perhaps in an installer or GUI somewhere, where you say, I want to create an RDW instance, and it goes off and does all of creates all the pools you need for that in the background with the right DNS.
Yeah, but I think logically, you still have, because we have multiple file systems consuming the same pool, you logically still have the create pool bit. But then I guess, okay, it doesn't matter so much what the command lines are called when you've got something else layered on top of it. My brain is worn out of this subject.
Really been envisioning this application.
Or I can just keep having the dashboard scan for the RBD directory object.
I mean, maybe it's just me. I've definitely been this application set stuff is sort of a bridge for existing clusters, and that where we want to end up is everyone like with workflows in Ceph Manager where they, give me RBD storage. And so that workflow is just going to be invoking commands under the covers. Is that not what you're thinking, John?
So yes, but you'd still, I think what we sort of helpful, simplified commands that are protocol aware and do it all in one step. We probably still also need, and this is maybe on a per application basis or maybe globally, a simplified pool create command that lets you say, what protocol it's going to be for, or like what drive type you want, for example. I forget where we landed with the device classes, but for example, I shouldn't have to run like extra commands to set up a pool that uses SSDs. I think at the moment you still have to explicitly create a crush rule, maybe, or not. I don't actually remember.
I can remember.
But anyway, you would have like a higher level pool create command, and in addition to that, you would have higher level application specific ones. And if someone used the application specific one, like by default, it would probably go and create the pool for it. So I guess the short answer is yes, this should all be hidden behind higher level commands. But it still niggles me that the command for marking a pool for use with RBD is going to be called metadata set.
Well, if you look at that, I changed it to Ceph OSD pool application enable foo application set with the metadata.
And again, I'm more than happy just to add a new RBD CLI that is
that
create pool or whatever, a knit pool or.
Yeah, we can also do purpose-driven like pool sets. We can add, instead of application enable, we can have Ceph OSD pool enable RBD so that they don't typo it.
Well, if the RBD CLI does it, then we don't need to clutter the mon one. And for CephFS, it'll be, Ceph FS new ... We'll just do it, right?
Yeah, I've been wanting to make a version of CephFS new that created its own pools forever. Anyway.
And even if you don't, it'll just enable application as part of its work.
And by the way,
yeah,
it's a lot easier now than it used to be, because we have a cross-monitor proposal or cross-service proposal system in the monitor now that would let you actually do stuff within one command.
Oh, is that safe now? Because we already have like the calling into OSD monitor from MDS monitor to blacklist things. Should we be doing that differently now?
Not that. This lets you do stuff like, I don't think there was a good legal way to do pool creation from the MDS. And I think
Now safely atomically update both the FS map and the OSD map in one thing. That's all.
Oh, that's good. I think the blacklist thing we do is still a tiny bit.
Not quite right.
Yeah.
Yeah. Okay. Well, I think we've probably beaten this horse. Is this acceptable? What's here now, or do we need to come back to it? I guess it's warning goes away.
Do we still need the map of the maps, or because we're already saying we're not even testing this to do like CephFS and RGW mixed together. If you're doing it, you're doing it. I mean, if they happen to have metadata that conflicts with one another, it'd be the same thing with having an object that conflicts with one another.
I think the map of maps still makes sense because I mean the deconflicting use of namespaces was something we were never going to be able to do properly anyway. But putting the metadata keys in separate maps is trivial and helpful.
And so the mon will issue a warning if there are no applications enabled for the pool, basically. This pool is unlabeled.
Ooh. So if we do that, then people are going to get a health warning between creating the pool and running RBD. Oh wait, no, it's RBD create pool, right? So they have to create it directly with RBD, or they'll get a health warning until they. Right. Okay. That's good. Yeah. Okay.
And RBD will fail. We'll still have some limits.
actually,
And this pool crate doesn't change.
we already do that for a lot of the pool warnings anyway. We should do that here too.
Sorry, do what for them?
We can key the warning on whether the pool actually has data in it or not, so that it doesn't show up in those intermediate states.
Yes, yeah.
So the only annoying thing about the having RBD create pool and so on creating pools is that there are like 4 different optional arguments for creating a pool, specifying it's not just the PG_num, it's also which crush rule you want to use, whether it's erasure coded or replicated, and what erasure code profile you want to use.
And the expected number of objects for file store.
That was when I did it yesterday.
Yeah, although that one we can probably lose.
That's important for RGW, for sure. But
yeah.
for the time being.
So this is, I mean, I think even in the glorious future of GUIs wrapping all this stuff, you're probably still going to have an explicit create pool bit for exposing all of that stuff.
But it'll be an enlightened consumer of that, hopefully, that API, I guess. I guess the other thing here that create pool is probably going to want to do is it's actually going to probably create a set of pools, because it's going to create the erasure coded pool for your data pool.
Yeah, if you want to configure it, that you're doing coded. You have to specify here's your replicated, here's your
you'd
data.
actually say RBD create pools, and you'd say
maybe it's still more along the lines
profile. Boo. Yeah. And then it will go create your metadata, your regular RBD pool, and it'll create the EC pool with the right profile. So that still makes sense. Okay. All right. Whew.
Just one question. With regard to the map of maps, how do we handle multiple applications, multiple instances of the same application there?
They would live within their metadata, I would say. So RGW would have a key, and then underneath it would do whatever it wants. It'd say like have a list.
Right, but if you run one zone instance and the second zone instance, would the application key would be RGW, or RGW the identifier for the instance?
Well, if I was building a high-level tool that wanted to separate out what the pools are used for, I wouldn't want to have to scan for
Yeah.
RGW XYZ, I would want to scan. If this is RGW and below that is, I now know how to then do extra scanning
Right.
to know.
But
And you probably wouldn't put multiple RGW zones within the same pool, right?
we have an issue where like the root pool is being shared by all, right?
So in that case, I would say the top level key is RGW, and then within your key value metadata, you would say zone dash identifier equals 1 or something for all of the zones that consume it.
Yeah. So the keys would need to do. Yeah. So.
Okay. All right. So we good to move on? We spent an hour talking about.
we suck at simplifying things.
I know. Yeah. So this next one is an attempt to simplify things. So we were talking about a replacement for Ceph disk that uses LVM instead, which we could talk about later. But one of the issues that came up during that is that one of the sort of ongoing headaches that we have is the support that's sort of half-baked originally in the sysunit scripts and partially carried forward in the systemd scripts is the ability to have multiple clusters on the same host with different names. And the way we sort of kludged this in was that since we already had a ceph.conf, the default cluster name was Ceph. And so the conf was cluster.conf. And so you could have foo.conf and whatever. But in order to use any of those, you have to do like on the CLI, you have to do -- cluster and then the cluster name. So the original motivation for this was that I think it was like Deutsche Telekom was like dreaming up this like big multi-cloud craziness. And they're like, but we're going to have hosts that are going to have OSDs from multiple clusters. Can you do that? And we're like, sure. And so we wrote it. And then I don't know that I think there's some users who actually use it. Jason's raising his hand.
RBD mirroring.
RBD mirroring uses it? Oh, God. Okay. Okay. So let me just summarize the status quo. In systemd, it's only partially supported in that all of the daemon instances, systemd only has a single field for the like instance identifier. And so that's the mon name or the OSD name, which means that the cluster is basically hard coded and you put it in etc sysconfig or etc default /ceph. You say cluster equals foo, and that defaults to Ceph. And that's so for any given host currently on JUL or later using systemd, you can only have one cluster per host, but you can still name it. If you want to do multiple clusters, you have to use like containers. And then because they have their own etc whatever, or you have to pass it on the command line for like everything. So the hope was that we could kill it because it's like annoying, and I didn't think that anybody was using it. Although I'm eager to hear what Jason is doing.
I also heard of actual users using it too, so I don't think it's not. I don't think it's entirely unused.
Yeah. My sort of follow-on question.
I was to say the only way RBD is using it is basically to load a named config file for another cluster. I mean, yes, you can do the same thing with that, the Ceph OSD daemon can do, where it says like, hey, my config file is not ceph.conf, it's XYZ, but when it's trying to load the information to go talk to the remote peer, you name the remote cluster by the name of your cluster config file.
Mm-hmm.
So it's really, the daemon itself bootstraps up with one cluster, the local cluster, by default ceph.conf, but the same thing, systemd, you can override it to another cluster, but then it uses metadata within the pool to say, and your remote peers, they're named XYZ, so go look for xyz.conf. So that's why when I say RBD uses it uses it in that respect. It doesn't,
It doesn't need to set up. Yeah, so I guess the question is, the systemd restriction seems to have nobody seems to have noticed, because if you're running JUL, you can't have multiple clusters on the same host. You can just name them. Does that jive with what you've seen, Josh?
I'm not sure. I definitely seen people reporting issues with init scripts in the past when they run into this. So I wouldn't be surprised if there were some reports of the system D issues too. Just we haven't noticed.
This, which is what your doc says here at the very end.
The open office.
But it doesn't seem like it's that big of a maintainability nightmare to just pass an extra argument to every Ceph command that's indicating which cluster to use.
Okay. Again, this is a separate.
Because it's not a very complex piece of functionality.
Yeah, it's just annoying that the original purpose like isn't useful anymore. Like it's at this point it's like mostly cosmetic. So it means that it clutters at the mount names. So the reason why it's varlib ceph osd ceph-1 is because the cluster name is there. So it's just annoying. And in reality, if people are going to be using, in sort of the future world, if people want to put multiple clusters on the same host, they're going to be putting them in containers. And so we didn't really need to do it. So the only really use, it's either A, you want like this cosmetically, you just want to call your cluster foo instead of ceph. Or this thing that RBD is doing.
The other thing that I want to add here about custom cluster names is that this has been supported for a while, but even today, we're still having issues in places where -- cluster is not being passed, or is being passed incorrectly, or it's missing. Ceph disk is one of them that was just recently fixed. Deployment tools like in Ceph Ansible, we're still struggling to really nail these. And it is so pervasive that pretty much all of the tests in Ceph Ansible use a custom cluster name just to be able to catch these instances where we're not doing it correctly. We're still hitting issues today, and this has been going on for a while. So the thing is that custom cluster names affects everything. And it's difficult to make everything work with custom cluster names.
So without saying anything about like whether they should exist, I kind of really agree with that it's kind of a gun pointed at your foot. So when people try to write user interfaces, they have like a create cluster page, and they naturally go, oh well, I'll give them a field for saying what their cluster should be called. And you see the wireframe, and you're like, no, don't do that, because they'll have to spend the rest of their life typing -- cluster after Ceph every time they run it. Yeah. The current implementation is definitely there.
So what are our options? I mean, we can do nothing and just continue to like discourage GUIs from letting you set it. We could explicitly deprecate it, or I don't know what that even means. We stop any news. Yeah, well, the upgrade path is you just rename your ceph.conf, actually, because that's almost all it is. And you reboot your box so that they all mount in the right location.
And your ceph.conf is probably already renamed anyway, right? I mean, that's...
Well, if you have a cluster name of foo, that's foo.conf, you just have to rename it back to ceph.conf.
Or start using -lowercase c. You know, it's almost literally translating from uppercase C to lowercase c.
Yeah. And all the log locations and ASOC locations and other files all differently in different locations. Like that's cause a lot of pain.
Okay, all right, I'll do that.
Yeah. But how many people are doing it, I guess? And it's a one-time pain, and then we've dropped this like maintenance.
Well, we could also start by disallowing that in deployment tools. So if the deployment tools are saying we're not going to support custom cluster names, I mean that's already a pretty big chunk of people that use that.
Yeah, I guess that's fine with me. The taking it out of systemd support is fine with me. It's the taking it out of the CLIs, like being able to specify -- cluster is. again, using the RBD mirror use case of like, oh, you're watching test cases run through, like now I'm actually going to have like 2 hosts where I've got Ceph and Ceph, and I'll have to, in order to like go check the stats on another cluster, I actually have to go over to a node that's only configured for that cluster to go, use the tools against it, as opposed to just remotely connect to the other cluster to, see what's going on.
So and I tried to move this along. So my proposal would be, 1, remove it from Ceph Ansible and remove it from Ceph deploy. So any new, to the extent that anyone cares enough to go past Ceph deploy. So no new clusters will use it. That'd be step 1. 2 would be, since systemd already doesn't support multiple clusters on the same host, we remove the cluster from the path name for the OSD mount directories. Since those are dynamic anyway, Cepdisk like dynamically mounts it in that particular location, then we can just sort of simplify it there. The only thing that's going to break people who manually mount their OSD directories, I guess. But there aren't very many of those.
It is certainly going to break a bunch of things. I am pretty sure we rely on parsing of names. I mean, unless we're going to, like if we say no custom cluster names, if that means that we're taking the Ceph dash portion of the mount location of the OSD, then all of the bash scripts everywhere that parse that location and split will need to be updated.
Well, those are all Cepdisk. We could leave Cepdisk and just make Ceph LVM.
It's not only Cepdisk. Ceph Docker parses IDs like that. Ceph Ansible does that.
Anything that monitors Ceph by going and finding the admin sockets is going to be doing that parsing.
All right. Well, so we can just remove support from a deployment tool then. I guess that's all we can do. And at some point, there will be nobody who uses it, and we can.
Yep.
But I would encourage us not to do that anymore. Try to clean that up, I guess. All right. Fine. There's not much we can do with that one. Okay. Anything else on that? The next one is killing the default pools in the cluster. It's weird that when you create a cluster, an RBD pool is there already when you might not use the cluster for RBD. It also complicates the deployment tools because they have to make sure that that pool is created with the right number of PGs instead of waiting until later and then to making an explicit step. So I think Greg is already doing this right now, but I just wanted to open that up for discussion, make sure nobody is screaming and saying that's a terrible idea. I don't hear any screams.
No screams.
All right. That was easy. The other thing on my list is the manager dashboard. So I sent an email to the list, or there was a thread last week about this, adding all the RESTful stuff. There are now 2 new modules in the manager that are sort of enabled, not enabled by default, but are shipping by default. vStart enables both of them now. One of them is the dashboard, which is basically a Ceph-S webby thing that I mentioned earlier. You basically have to go set the config to tell it what IP and what port to use, and then it'll turn itself on. It does not support SSL at all. It's just HTTP. And the other one is the RESTful dashboard, which requires SSL. And there's still some cleanup I think we need to do with how the cert is generated there. That's also set up by, run by vStart for you and can be enabled in the future. But I was just sort of annoyed by the lack of symmetry there. I can't remember exactly where we left this. My recollection is that I think for the RESTful one, we want to make it so that we don't use the OpenSSL CLI and the package install script to create the cert, but instead the module creates the cert on demand if it's started and doesn't have one already configured. But it makes me think that maybe the RESTful or the dashboard should do the same thing.
But the reason they're different, of course, is the dashboard is read-only, and the RESTful is an API that allows writes to the cluster. So
yeah,
if we change our mind with the dashboard and have some cluster modification, then we absolutely need authentication there. But until then, maybe it's okay.
I think it's also that the RESTful has authentication tokens that it's protecting, whereas dashboard being read-only doesn't.
Yeah, so I definitely agree that SSL should be required for RESTful.
Do we ever again see the dashboard getting advanced capabilities? And if you do, why don't we just make it SSL right now and not go down that path?
Here's what I think about that. At the point that we start adding stuff like that to the dashboard, we'll have to stop calling it a dashboard. But you have to do the security bit properly. And having something that generates a self-signed SSL certificate is better than nothing if you're trying to protect some credentials. But it's a bit of a stretch to call it SSL because it's not, right? The right way to set these things up is to have an administrator or tool or whatever generate proper valid certificates. And sadly, you can't. There's no way. Well, you can't do that in a self-contained way because you don't know what client certificates they have in their web browser. So I think there's something to be said for not pretending and just saying, you know what, it doesn't do SSL out of the box because it's impossible to do SSL out of the box. And maybe if we add the SSL bit to dashboard, we can still make it the case that by default you get normal HTTP read-only. And at the point that you want to enable people to do things like delete your pools over that HTTP socket, you better have a really good security story on it, right? Rather than doing something, half-assed.
Okay.
I tend to agree for what it's worth.
Yeah. I mean, I definitely get that it's okay that it's not SSL now. It just is weird that you can't even add SSL, but that makes sense. Okay.
You're muted, John.
You're muted, John.
Sorry, I think the most important workflow for the RESTful module is not the creation of self-signed cert by default. It's the process by which the user can configure it to be properly secure. It's the process for loading in the individual SSL certificates for each daemon. That's what really matters there, because the RESTful thing is writable and can destroy all your data.
So maybe the thing to do there is just remove the piece in the packaging that automatically generates a cert and just require that you set a cert before it'll start up.
That's kind of my preference, but I'm conscious that I'm a little bit of an extremist, so I didn't want to kind of unilaterally push too hard for that.
It feels like there's gonna be a documentation page that says these are the 4 steps you take in order to enable the RESTful API, because you have to set the IP to bind to and you have to set the port. There's just going to be one more command that to generate a self-signed cert, paste this command to generate your SSL cert and also set that, right? So it's going to take them an extra 10 seconds to like paste it into their terminal. So I'm not sure that there's value in the package doing it because there's still manual steps to turn it on anyway.
Yeah, I wonder if I was about to say I wonder if for some people they would like it to have a non-HTTPS mode for their like development environments and stuff. But again, like you were just saying, there's still a manual step for enabling it. So I'm not sure what the point of that would be.
So vstart just runs SSL, OpenSSL to generate a cert and sets it, right? It's like 3 lines. So we would just put that in the documentation, which we need to write before we release all this stuff. Okay. That works for me. Should we move on to Ceph volume? All right, Alfredo.
Yes. So let's see. I am going to be talking a little bit about Ceph volume, which is currently it's just a proposal of writing a new tool to try and deal with deploying and managing OSDs. Parting ways a little bit with Ceph Disk. So I'll give an overview of what the current state of Ceph Disk is. What are some caveats that we're looking at? Some of the ways we're thinking that we can change or improve the deployment process for an OSD. Then what we are actually proposing and some of the caveats there as well. And go into detail about those. So right now with Ceph Disk, it basically will want to do partitions everywhere, regardless of what device it's going to consume for an OSD, for setting up an OSD. The reason it does that is because most of all the pieces, I would say all the pieces that interact with an OSD to set it up and bring it up and start it, stop it, and manage it, basically deals with reading GPT labels. So behind the scenes, we're slapping a bunch of different GPT labels on disks and partitions to identify if a certain partition is an encrypted device, an encrypted file store, unencrypted, regular journal, what's the state of that. And there's a bunch of different UUIDs that identify each one. Not only Ceph Disk reads these things and interacts with that, but also other projects like Ceph Docker do the same thing to try to identify these things. Ceph Docker doesn't use anything with UDEF or system D scripts. It provides its own set of tools. So it kind of like uses a little bit of the GPT labels to try to identify and work around that. So all of these things are tied together to make it work. So they're very, very tightly coupled. Currently, we have situations where certain OSDs don't come up because we rely heavily on UDEF. So UDEF has certain events that will call onto Ceph Disk to activate OSDs, mount them, and make them available. But the problem with UDEF is that, or this whole workflow where from UDEF it goes to Ceph Disk and to systemd and back to Ceph Disk and back to systemd again, it's really hard to debug. When something doesn't come up, it's unclear because of this workflow, and because we're primarily relying on UDEF to fire these events in a proper order. We get into situations where we just don't understand why a box rebooted and some OSDs didn't come up. It's hard to replicate, if not impossible, because I mean it's just asynchronous in nature. So, and the other thing, and I think it's primarily why this whole thing started, or like trying to rethink this, is because we want to support devices like DM cache. They are not an actual device, but it's actually like more of like 3 physical devices acting as one. Very like LVM logical volumes. And it is currently very, very tricky to make it work with Ceph as is. And again, Ceph will insist to make partitions. So if you're presenting a whole, like something like a DM cache logical volume, Ceph will try to create partitions on top, which is, I mean, it's not an ideal way of setting up something like that, or consume a volume like that. So the current workaround of people who deploy logical volumes or things like DM cache is to use the directory, the OSD in a directory option from Ceph. So the way that works is just point at a directory, you create the bits and pieces that the OSD needs to live there, and then you're good to go, because you're using this as a directory where you might really be using it as a real volume. So what people do is they mount this volume in the expected location, and then the OSD just starts. The caveat with that approach is that they no longer can rely on UDEV or UDEV to be able to mount these things. So what they do is they write directly on fstab what the device is and what's the destination, what's like the source and destination for these things to mount, instead of relying on the whole GPT label thing that does that automatically with Ceph. So that's kind of like the overview and how we're coming to think about how to support these things. So a few things are needed for managing and deploying OSDs. We need to know what the source of a mount point is, what the destination is. Sage mentioned at some point that the flags are really not needed, but if any specific flags are needed for mounting these file system, those things are consumed as well. What type of journal configuration what strategy? For example, in the case of DM cache, sometimes the device itself or the logical volume is so fast that people are just using a regular file to write as a journal, because like they feel like it's good enough and it meets the needs, even though like the actual logical volume would have I think it's 2 writes all the time. And then the encryption keys, if encryption keys and type of encryption, if encryption is needed. So those are the bits and pieces that we would need to know to try to understand how to properly deploy an OSD and bring it up and make it run. And the current approach is that we keep everything within the device. So that's one of the reasons why we create these partitions. We store things within the OSD. There's this special partition called a lockbox. So, for example, in the case of having a device and you want this device encrypted, you will have a partition called lockbox that will have that is unencrypted, that holds the keys, that will save you from losing those keys if the OS were to crash or get corrupted in a non-recoverable state. So you would be able to get this device, take it out, put it somewhere else, and I would say mostly be good to go, because of the configuration and the keys are inside of the device, like it lives with the device. So thinking of being able to consume the volumes as is would have to shift away a little bit on the workflow that we've been relying on. One of my concerns is that I don't want to specifically say I want to support this type of technology. For example, I don't want to say, okay, I'm going to support specifically the use case for DM cache, although it would be easier because I want to kind of like have a way of supporting any volume that I can consume and say, okay, you gave me a volume, I'm just going to make it work as an OST with certain constraints, of course. But going back again to the partitions, the problem is that we need to think about what the workflow is, like given all of those constraints that we have in Ceph disk and where we put keys and where we put configuration and how everything's tied together to mount these things and make them work, how to make them work without having partitions. So in the case of LVM and DM cache, what we were discussing with Sage was the approach of overloading the name of logical volume and a group. That way, by just looking at the name, we could say, oh, this is a file store, it's encrypted, or it's just unencrypted, or it's something else, and give us information that we need to go ahead and mount it in any spot. Or in the spot, actually not any spot, but the actual spot that we think by convention where this thing should live. So the good thing about that is that we will be able to take our whole LVM group, put it somewhere else, and that would still work because the name would survive. Like LVM will store its metadata within the devices itself, so that would totally survive. But the thing is that we, by defining this schema, this naming schema, we get very, very, very close to the character limit for naming logical volumes, which is 126 characters. Just by using some of the defaults and using some of the strategies of the naming conventions that we were discussing last week, we were getting too close to like 115 or 118, I think, characters, which would be fine, except that I'm fairly certain that at some point in the future, we're going to want to add some other bit or piece of information to that naming schema, and we're going to not have enough space, or we're going to get into trouble. So the workaround here is that LVM allows you to have any number of tags associated with the logical volume. So that fixes that problem. That is also stored. It's basically like having custom metadata in your logical volume. So that's really neat because there's no longer a restriction of what is it that we want to store there. We can store as much information related to Ceph as we want, and makes device discovery as well pretty simple.
It seems like assuming that we want to go down that road, it seems like the obvious thing to do would just be to take the cluster name, but the cluster UID out of the volume name and put that as a tag. Because mostly you don't care. It's rare that it's going to matter. But then the rest of the name is still going to be like Ceph OSD, which is nice and descriptive. And for an admin. And then the UID for the actual OSD seems like it needs to be in there. There needs to be something unique in there.
Now, to me, the caveat of doing that is that this would just be a special case for LVM. So there are other caching technologies that are not based on LVM, so this wouldn't work for that use case. And it wouldn't work also for regular disks that are not LVM-like. Of course, I mean, we could kind of like, I guess, work around these a little bit and try a bit. Like I think I'm more enticed of having like a single way of like looking at these devices and dealing with them. It's not only setting them up, but it's also the discovery. So if another caching technology comes that it's LVM-like in nature, it means that we would need to find a way of like having some sort of discovery. Now, when we were discussing this last week with Sage, we said, well, in that case, we could sort of like describe like really accurately and describe what is it that the constraints that we want for any device to be mounted and working as an OSD. And then we would just be able to like mount it and get it going. But it's the setting up that is the having like kind of like the special case for LVM, because it would be just LVM, and we'll still have to do something different for disks.
I would like to ask a stupid question.
Yes.
Why can't we put all of this in a config file and just execute that rather than try to encode everything onto drives if we don't need to hot plug drives anymore?
This is why, I mean, this is great. Thank you so much for raising that question. So one of the things that I did is that I also met, I mean, this is not just me sitting in the corner trying to come up with these smart ideas, or not so smart ideas. But like I went, met with Sage, met with John, Greg, Dan, I met with the DM Cache people, the LVM people, and asked, okay, what do you think? What would make sense here? So after actually meeting with John, and he said, well, we should maybe like have like static configuration here that just says these things and what is it that you need to mount them. So I started tinkering because like it was impossible to deploy DM Cache as is. So I went and did it all manually. And the initial approach I took was, well, what would be the way to tell a system to mount this thing correctly in the place that I'm looking for that is just fairly transparent? So the way to do that is with FSTAP. Now, mangling FSTAP in a sort of like kind of like using it as a database of like adding OSDs and removing them, because that's kind of like what deployment would be doing. I thought, well, maybe there's a way to define different locations for FSTAP files, and so it happens that there is a way of where you can say you can specify where you want what FSTAP should be consumed by mount. So what I did was I defined, and this is all proof of concept. So what I did was I defined a structure which is very similar to the Ceph OSD structure that we follow in Barlib Ceph. For Etsy. So Etsy Ceph, OSD, and then the cluster name dash OSD ID, and then a bunch of different metadata information there. So this FSTAP file had the definition of this one OSD. So I would go in, try to say, well, this is the OSD location. I'm going to mount it here. And then the systemd file would be generic enough and say, well, I'm just going to start for OSD ID, let's say 0, and then it would look at these path exported, export or passing the variable so that mount knows what FSTAP to use and just use it. Now, that would allow us to have this one out that we currently don't have, which is what happens when UDEV fails or systemd is bad or we have a bug in our code. That approach allows us to say, well, if you as a user you're having issues because we messed up here or something else is not working, you still have a perfectly transparent FSTAP that is pretty generic. Everyone can understand or should understand how it works, and you can consume it as is. Of course, modify it as well, but like I wouldn't recommend modifying. Like that would probably be more of like the part of the deployment of an OSD. So this is kind of like the exciting part. Now, for me, now the caveat of that whole approach would be, of course, we would be doing without the current ability of everything's stored in the device. Keys are there, anything special goes into the logbox partition, and that can survive the OS collapsing. If you have encrypted devices, then you can say goodbye to your keys if they were stored in etc. Ceph, as it was the case before we had the whole logbox approach. So that's the caveat. But for me, it would mean that we could support. Go ahead.
I think that's a really big deal, by the way. Storing the keys around distributed next to the data that they encrypt is a really important feature that I don't think we want to lose.
Yeah. So now,
well, I think it's important to separate out the different environments that this is going to be used in, because in something like a Docker container, then yes, just write everything out inside the container. You write the config file in Ceph, you write something in fstab that however wires up the device, and then start it. You can just hard code it into the container because it's not hot swappable. It doesn't need any of that dynamicness associated with it. But in the more general case, we have to make sure that we support. We need the lockbox concept so that the information you need to get the decryption key is with the device, and the failure of a boot disk won't destroy all the keys for all of your devices in the host, for example. Right? You need to do that. We need to maintain the ability to have the key and some escrow key manager service or whatever.
We could still have, not a partition, but make it another logical volume that stores these things. In the case of LVM, which is possible given a certain setup. That today I was overviewing what are the ways of setting up the encrypt with LVM, and one of the ways is being able to do that.
Partitions and logical volumes are roughly equivalent in this discussion, and the tags on partitions and the names of the logical volumes are roughly equivalent in this discussion.
Yeah, the LV names are a little bit more expressive.
But the point that you've got some unencrypted bit of your device, whether it's a partition or an LV, what's to stop us just using that for everything, right? So the same config file that we would put in etc Ceph, okay, if we want the drives to be self-contained and hot swappable, put it in the, what we're calling the lockbox, right? It seems like writing a script that parsed a config file that said, here's the UUIDs of the devices I want to use. Please mount them for me so that I can start this OSD, is a much simpler task than coming up with a scheme that sort of self-represents the IDs of things and how they're related. It feels like, I know this is easy to say when you're not having to write the code yourself, but it feels like we're making this harder than it needs to be.
I've been kind of waiting for someone to ask to put the config file on the device because I've kind of wanted to do that for a while, but have not.
Now,
and I guess one answer is without encryption, you don't need any magic partitions, and so this would be a new requirement on non-encrypted drives. But it's perhaps still a good requirement. We need something simple that we can always access, encryption or no, that we can find to understand the nature of this device that doesn't involve mounting a data partition and parsing the file system there. Or maybe if we get to that point, maybe it doesn't matter if we open the data partition and parse the information there.
So we've mentioned Spanish fading, so sorry if I missed this, but it sort of seems like from the pad and some of the discussion that a lot of this is about trying to get all the information locally available in a way that the local system can make decisions without the orchestration stuff interacting. And that sort of makes sense that you want you want the server to restart and for it to turn on, and that makes sense. But it's not clear to me that trying to have everything go through one tool to set up the devices, and that we do the same, and that every OSD in the world should look basically the same from the perspective of outside stuff is reasonable.
I agree. So what I tried to do in one of these sections here, line 85, is my thinking was Ceph disk isn't going to go away because you have all these legacy OSDs that work that way. We probably want to do something new that doesn't involve UDEV, and Docker containers are going to do something that's simpler, hopefully. So try to like feed all of these through a common state. And so the simplest is just like, what is the state before you start the daemon? And it's basically, you know, it's mounted at a particular location in varlib to start the unit, the systemd unit. And then all the symlinks in that OC directory resolve the devices that actually exist. So when you point out to the journal device, it has to be there before you start the daemon, that sort of thing. And as long as you get to that point with whatever manual configuration or tooling you get, like you can still proceed. And the thinking is just that you can have
the way we want to go, though. Like,
what's that?
I'm not actually sure that's where we want to be. And like, do we really want everything to have the same symlink set up? Like,
they don't. I mean, no. They can point. That's the idea. Is that the symlinks can be to whatever they want. It could point to dev SDB3 because you manually set this up. It could point to dev mapper something that I like manually configured with ICAS and LVM, or maybe it points to like my RAID controller. It could be whatever you want. But as long as you have it mounted, then you're allowed to start the daemon. And so then you can create in theory, a variety of tools to like get to that state. Ceph disk is one of them that already does that using a very fragile set of UDEV rules and GPT partition labels and so on. LVM might be another way to do that by just having, at the simplest case, just a standard way to label the OSD data partition so that a systemd unit file can look at the logical volumes, and whichever ones look like OSDs, it'll mount them and start the daemon for the LVM variant of hot plugging.
So Sage, this is kind of how CBT works. We basically give a label, and whatever's sitting there, CBT just uses. I'm not sure it's actually that great, though. A lot of people have been confused by this.
I guess it seems like maybe this is the way to go, but it seems like we're having a lot of trouble, and really all this buys is that we can use the same like init scripts, right? And it seems perfectly reasonable to suggest that different deployment strategies should use different init scripts.
I mean,
well, these would need to have a different systemd file. I mean, this wouldn't work as it is right now. It would just not work.
This wouldn't work. Well, I think that the Ceph OSD @.service files, like unmodified, will work perfectly with this. This is just describing the status quo. It's just describing in enough detail that someone could go manually do it. So right now, Ceph Docker is doing its own weird thing, and they kind of like reverse engineered it. They should basically should have been able to look at this and say, oh, I can write an etcfs tab that mounts it in the right location, and then I run system control start Ceph OSD, or manually just run the daemon, I guess, if they want to do it that way.
So thinking on it a little bit more, the thing that people who have used CBT that complain about kind of this same type of problem have kind of usually advocated for something like what John said, basically a configuration file that they just want to be able to stick like /dev/svd in, or /dev/ NVMe1, wherever the partition is there. That's kind of been what people have kind of generally asked me for. Not saying it's right, just that that's kind of what it seems like a lot of the people that have wanted to use it have wanted.
And the reason I think that's the case is that like different environments and OSs and deployment strategies have radically different expectations about what they have going in and what they need going out. And if getting those symlinks set up is the hard part, then we should just shortcut that And if it's not the hard part, but we're like our energy is focused on that, then what's actually happening is that we're obscuring what the hard part is in a deployment strategy and trying to get the symlink and phrasing it in terms of getting symlink set up when we should be looking at how in this deployment strategy do we turn on OSDs.
Well, we're calling them symlinks, but it's just conventions about where in the OSD data path the various sub-devices live, right? A journal doesn't even have to be a symlink. It can just be a mount of whatever you want there, or however you want to arrange it. The real convention is that we have an OSD data directory that has these fixed items in it. And the reason that it's nice to be able to have partition tags or names of the module volumes is that you don't have to mount and do file system I/O to figure these things out. You can do them from basic inspection that doesn't involve disk I/O and doesn't involve understanding the file system. Maybe that's not important enough to matter anymore, because maybe it's always easy to mount it and query it.
That seems like saying we shouldn't. It seems to me like that's like sort of the overall cluster architecture is intimately tied into those things. And so trying to be blind about where you're running is a recipe for being miserable all the time. So, I mean, actually turning on an OSD daemon, it just needs paths to it like you can pass it in on the line, and it supports a bajillion different things, right? And
yeah.
So
you can still do that, but
but it can
when
do
we're
that.
trying to like reduce the number of variables in a way that doesn't actually reduce your freedom, right? And requiring just that you mount it, that is already mounted before you start the daemon, and it's mounted in, and asking that they put it in the default mount location instead of some random one doesn't feel like it reduces your freedom.
Well, I mean, it means that you need a system that is capable of doing that symlinking, which doesn't seem like it would be hard, but I mean, there's just lots of random things out there, and I think part of the story of Ceph disk is actually hard.
Yeah.
Just supporting different init startups for different kinds of deployment.
I mean, feels to me like the big takeaway from Ceph disk is that the asynchrony of UDEV is like a nightmare. That feels like the biggest lesson learned. I guess my goal would be to allow an enlightened administrator to say, I have a disk, I want to use it. I want a simple step to like turn this blank disk into an OSD that I can start. And without having to write a bunch of scripts in the simplest way possible. And also have another workflow that's like, I don't know anything, I don't care. The system, just do the right thing, do whatever you think is best and make it work. So you need like the dumb user administrator, make it simple. And then you also need to have a layer down, have an enlightened administrator be able to like prepare their volume and just say, go use that, right?
That last one, I think, is the important one. I think a lot of system administrators already have their own way of like doing things, and they want to be able to just say, I've got my own tooling for deploying disks and setting them up. I just want someone to take it and run with it.
Well, I think they're both important, but I want to. This is just probably preaching to the choir here, but we've historically emphasized the making you do anything you possibly want by having every possible configurable, and somewhat neglected the fact that we need to make something that's simple that people can make just work. And so I don't want to lose sight of the fact that there should be a command that's one line that says, go create OSD or OSDs out of these devices and use your best judgment. I don't know if it should be file store or blue store. I don't know if I should be using SSD caching or not. I just know that I have 5 SSDs and 12 hard disks. Make the best possible use of them.
Yeah, so
and that should absolutely be a workflow that we.
And that makes sense as the sort of the thing we support with our default init scripts, and that we do when you give us a thing that looks like a perfectly normal server. But that doesn't mean that when running in Docker, where you have these weird ways of making sure that like when containers move, their storage is still available. That doesn't mean that that's the right model, or that we should be going through the same paths for that.
It isn't. That's why they re-implement their whole thing differently. Like they use their own systemd service files.
That we want a magic tool that no matter what we give it does the right thing, and I don't think that's the case.
Yeah, the thing is, I think I completely agree with everything you're saying, but I think you're misunderstanding what is written here, because there's nothing in here that says that. Like the whole point of this is that there's a single. The only thing it's saying is that you should mount it in a default location, and that doesn't prevent you from doing everything you just said. Like unless what it does do is it means that if you're writing the Docker thing and you want to mount it on /srv OSDID, then you can't use our systemd-unit file, right? Which I guess you're free to do, but we should make our Docker file mounted on varlib Ceph and use our standard systemd-unit file, because there's nothing preventing you from doing that except for just not using a completely random path name. But there's no loss of freedom. There's no loss of generality. You're just sort of steering them to the well-trodden path, and they have to do less work. And if we choose these things that you may or may not opt into, like maybe I opt into that and I can use our systemd-unit files. Maybe I don't and I go my own way. Maybe I use the LVM naming convention for volumes. Maybe I don't. Maybe I currently use Ceph-disk, or maybe I manually have a bash script that runs when my server starts up and actually explicitly runs each Ceph OSD daemon. Like if we choose what those sort of well-defined things that you may or may not opt into are, though, and choose those so that they sort of maximize the common elements that don't actually restrict your flexibility, then we'll have more people running more common scenarios, I guess, and we'll have less weirdness out in the wild.
I think that the point of contingency and kind of like where we are at right now is that we're almost on the same page, except on trying to decide what do we do with how we understand what's the source of these things. So I think with the initial setup and deployment, that's fine. We should be able to say, yeah, we're gonna accept this volume and make it an OSD pretty easily. I think that the difference is it very important to keep the ability of having keys and configuration live as much in the device, or can we do without that and just put them in etc Ceph OSD something? To me, like having getting this started from scratch would be easier to not have to deal with the extra work trying to have another partition or another logical volume in the group to store these things, and rely on something that tells me where these things are going to, like where is this logical volume or this device going to be living, so that I understand where I need to put it. But I think that's basically everything else is we're on the same page.
Yeah. So if I understood that correctly, I think what it is that, say you're saying that we can just mount these stubs in the right locations and use shared code, and that all makes sense as long as. But what that means is, but that means that we do need to have a certain amount of information at every step along the path towards constructing that environment.
Yes.
And in some deployment scenarios, the order in which we acquire information is very different. And so Alfredo's going through a lot of jumps to try and get information in the wrong order and then turn that into the right looking environment, even though the tools expect even though there's a mismatch between what information is accessible. And so embrace the fact that things are that's very different, and just it's perfectly fine to build a thing that that looks at a random disk and says, and because maybe in this environment it's easy to introspect the disk and says, oh, this is an OSD, I'm going to turn this disk on where it is as an OSD, and then go look and see if any of the other attached disks are OSDs. Whereas in another environment, you might start out with a config file that says, here are my OSDs and they're on these disks. And so in some of those cases, it's easy to go down the common path, and in others, we have information that's in weird orders. And so we should embrace the fact that they're just different, and go to the end goal of turning on an OSD and embrace having different ways that we turn on OSDs.
And you can do that, right? You don't have to use our system to unit file. You can write your own. But like that's not what we want to steer customers to do, right? We want to have them normally use a sort of a simple general way to do that so that it's understandable. We don't have to log into every single cluster and say like, what the hell is these mount points? What is going on here?
So yeah, I think we want them to, when they're in the same deployment environment, use the same thing. But I don't think that necessarily on Docker we want it to look the same as on hardware. I mean.
Yeah. Okay. Yeah. Yes.
And that's okay.
But there's no reason it doesn't have to be, right? There's no point in introducing variation where the variation doesn't give you anything.
Yeah.
I think that so the main difference between so this is like a mix. This pad has like a specific proposal for like how to name LVM volumes that obviously needs some improvement so that the names are shorter. But the main difference between what this does and what Ceph disk does is that Ceph disk suffered from exactly the problem you're describing, where it didn't know what OSD it was or what cluster it belonged to. It had to like mount it temporarily and like remount it, and it was like a mess. And the nice thing about LVM, and the reason why I kind of like the logical volume labels, is that you can just put them in the name of the volume, and so you know exactly what it is just by looking at the label.
Yes,
and
but
all you have to do is mount it.
But the whole world is not LVM, which is my pain
which is
point
fine.
here.
That's fine.
And
That's
then we're gonna need to come up with something else to say, well, how do we support this other thing? Like, I don't know, Bcache or
okay. So I had two realizations there. One is that you don't have to have your whole OSD LVM in order to make use of the LVM labeling for the data partition. So for example, if ICAS is a whatever, say you have raw devices with ICAS, or maybe you have to run some, whatever it is, you could still label the OC data partition as an LVM logical volume, and it just symlinks to dev ICAS, whatever it is, and everything would still work. Like you could still use the LVM system unit that automatically mounts the OC data directory and starts up the OSD. It just happens to point to a device that isn't managed by LVM. That's totally fine. It might be that you're looking a bit into the future, using BlueStore and you're using the SPDK library, so you're not even using block devices, in which case obviously LVM doesn't make sense. But in that case, also you can either have, etc Ceph could hard code, and the varlib Ceph could just be on the root volume. Like it doesn't even have to be a separate device, so that nothing has to be mounted, and the system unit file just sees it there and starts it. Like you literally have to do your sort of not using any of this automated hot plugging stuff. Or it could be that, I don't know. I mean, there's like no limit really. Like, but by making it simple, you can still piece these things together in whichever way.
All of the pieces to be plugged in at the same time, which I don't know how ICAS works, but with ICAS, you might have one piece and not the others. And so you need to not try and turn it on when you're missing pieces of OSD.
Which is why there, and you notice again, line 80 to 95, the simple rule is that as long as the directory exists and symlinks in that directory point to devices or files that exist, then it'll start. So just symlink to the devices that you need. It's like a poor man's dependency graph. And as long as that is satisfied in whatever way, whatever set of automation tools you want, then it'll go.
Yeah,
do the same thing inside Docker.
Symlink or don't, as long as the devices are available in these paths. And to keep perspective, the point of talking about things from the perspective of LVM is to simplify it from a block device that supports partitions to a set of block devices. That's less of a constraint than a normal block device. If someone comes up with a new disk technology that neither supports partitions nor supports names, and I don't know how it's going to be used. So I think we may be over worrying about all these other ways of setting up drives that might exist in the future. They're probably going to be block devices, and they're probably going to have names.
But the naming is my problem with the naming is that I mean, we're very close. Even if we take one UUID, for example, LVM escapes dashes, and we're getting closer to the limit.
I don't mean that to say that it's going to have exactly the same naming format as LVM. I'm just saying that it has a name that is user settable somehow, or it has partitions. It's hard to imagine that there will be block device technologies that don't satisfy one of those two. Now, we may have a valid concern that the stuff we're trying to cram into the LVM name isn't going to be crammable into every kind of block device, and that would lead us toward the config file somehow, somewhere thing.
Which is fine, right? Like
if we're willing to accept that we have to open the partition to do it, that's fine. You know, LVM itself writes labels in fixed locations on the disk so that it doesn't have to deal with a file system to be able to identify the disks. It's conceivable that we could leverage that sort of scheme somehow. It's conceivable that there are flexible ways of labeling drives that we could start using for Ceph that are less constraining than partition tags, less constraining than GPT partition tags. But the upshot is still all the same. If we can get by without involving the file system, it's less complex and it's faster. But if we can't, we're probably still okay. We definitely have to have that file system by the time we use the drive anyway. So a temporary mount just isn't that big a deal. But my point of this was going to an LVM style block device is making everything more flexible in an absolute sense, because we're now no longer incurring the assumption that there is a partition table on the device. That's all.
It also doesn't have to be the only solution, right? Like right now, your options are use Ceph disk in its very prescriptive way, or you're completely on your own and you do whatever you want. And we're moving to a situation potentially where you can either use Ceph disk in its very prescribed way, or you can use a new tool that uses LVM in a particular way that happens to be more flexible but not infinitely flexible, or you're on your own. And then the last piece is just that we document what on your own means so that you can not have to write your own system unit file. You can at least reuse our system unit file, which is, you know, one less thing to worry about and doesn't really restrict you. But you can still not do that too.
That like we're keeping it composable, because like
exactly.
It's like when you say that when I'm hearing when you say that your thing with Ceph disk is that UDEV is a nightmare, and when I was talking to Alfredo last week or 2 weeks ago about how Ceph disk is unmaintainable, and so he wants to write a new one that's better. And when I look like on this pad on line 17, it's talking about a tool that takes a block device from anywhere in any circumstance and does the formatting and the mounting and the launching. But I mean, the formatting like is the step there that I want to make sure that what we're thinking about is that we're doing this in composable tools.
Exactly. Yeah, I mean, that was actually my suggestion would actually be to call this Ceph-LVM. So this tool is the LVM way to provision OSDs, so that it's clear that it's not necessarily solving the world.
Okay, that all sounds
in that case
to me then.
But do you see a problem with Greg? Do you see a problem with just trying to consume any volume assays and just format it and make it an OSD?
It's that they can be different and have different requirements for mounting
and what does formatting mean? Like in every OSD backend requires multiple distinct block devices. Either it's for file store, it's the big XFS volume and a small journal. For Blue Store, it's a small XFS volume and a big block and maybe a couple other block devices. So there's always like the requirement to chop it up in some way. So you can't necessarily, you either have to choose LVM or partitions, right? So the common element between them is like once you have your volumes, the actual block devices ready, and you've layered on whichever file systems, you layer on file systems on some or all of them, and then you run Ceph OSD makeFS. Like that's the common piece sort of between Ceph disk and between LVM. We could try to separate that into a different tool, but honestly, I think it's the simplest just to document that and make Ceph LVM run Ceph OSD in the right way. I don't know that it's enough common work to like have another separate tool consumed by both that runs Ceph OSD makeFS for you.
Right. Just a slight shift of perspective there. You may not even chop them up. They're just block devices. They may be block devices that are parts of another block device or parts of a logical volume or whatever, but they're just block devices. You could have 4 SSDs and use them all individually for pieces of a Blue Store OSD. More power to you. It's just a block device. And then what formatting means is putting a file system on and putting the files that the OSD expects on them. Yeah. That's all.
Yeah. I think that the key thing though is that a single OSD is always multiple devices. So you can't just say like, this is my device of any variety, turn it into an OSD because we have to cut it out.
Right. It's multiple block devices, which may be on one physical device, but who cares?
Yeah. So I don't know where we are now. Anybody else have anything they want to add to this, or should we talk about specifics of how the LVM way of doing things could do it, or are there alternative proposals to not use LVM? Does anybody think we shouldn't be using LVM here, or?
Well, we have a big customer that wants to use DM cache, right? So that sort of dictates LVM for them at least. And surely there are other flexible schemes for using LVM that customers will want to use in the future. So it's an obvious path for Linux. It's not the only thing that we'll ever want in the future, perhaps, but yeah, it seems clear we want it.
Listen to the customers, do what they want, right?
Yep. So Alfredo, the issues that came up, one is the long names.
Yep.
So if we shift a bunch of stuff into tags, or even just the cluster name, that brings us down to like 80 characters.
Yep. I mean, probably... at that point, I would prefer just using tags other than overloading the actual name. I mean, of course, we could also put something in the name. I mean, that doesn't matter, but we could, for anything custom, we could use tags. And maybe we could just use for regular disks, we could use LVM as well. Same workflow, same strategy. I don't know. If we're going to go that route, yep.
Yeah. That was definitely my thinking, is that all the new suggested workflow would use Ceph LVM instead of Ceph disk.
Right.
Because we avoid all the UDEV headaches. There was an email just today about like somebody using dmcrypt and they reboot the server and the devices didn't come up, right?
Yeah. Yep.
I would love to have that go away. I think the main reason I'd like to keep at least some minimal information in the name is just that's what the administrator sees. So if they do LV list, they should just see it and know what it is. So it should have Ceph in there somewhere. It should have OSD in there somewhere, and probably like data, journal, wall, something, just so they know what the device is. So Alistair says he doesn't think we should wrap LVM DM cache.
Yeah, at least, he said that that's maybe something to think about in the future if we want to add that functionality. But he said that right now, if we can just work with the logical volume, that would be good. I still have a meeting with him next week to go step by step and further integration.
I can't tell if I'm interpreting that statement correctly, because one way of interpreting is that a tool called Ceph LVM shouldn't exist. The administrator should type LV commands directly. And that's sort of like an impossibly in conflict with the idea that we want a storage system that is usable by somebody who isn't already an experienced and trained LVM Linux administrator. Like, in order to have any chance of succeeding with any user base, we have to have a tool that lets you say, create an OSD out of this disk without having them go type LV PV create, LV create, right? Like that's...
In the simplest use case, I would agree with you, but DM cache is not very simple to
I see, for DM cache specifically, I see.
Yeah, so for a regular LVM thing, that's not that complicated. But DM cache, you really need to think not only about what your disks are and how you're going to chop them up to make them work and where things are going to go, but you also need to think about the caching strategy. What are you going to use this for, and what type of strategy do you want to apply for caching? So there's no good answer here, because even if we think one is better, maybe it's not the best case for RBD or
writing a DM cache administration tool is out of scope for Ceph, honestly.
Yes, absolutely. We should not be doing that.
Don't be sad, Sage.
Yeah. It feels like for 1.0, like just getting this to work and getting away from YouTube, that's the case, but expecting a Ceph user to be able to make an intelligent choice about how to configure DM cache is like, they have to go like learn the architecture of BlueStore. I mean, they have to be a BlueStore. It would be hard for us to do it, to figure out how to configure DM cache correctly. And so I think we have to have a tool that says, I have an SSD and I have 4 disks, or I have 2 NVMEs and I have 32 disks, or whatever it is, and says, thinks a little bit and says, this is my best guess at the best approach, and does it. Because expecting users to like know how much they should carve out for the BlueStore wall, whether the wall should be on DM cache or not, how big the DM cache volume should be. It's like, how could they make a good decision, right? And then every single cluster is going to be completely different. They're going to get weird performance where you're like, maybe you didn't set up DM cache. We have to have something that will like just work. It'll make an informed, programmatic, educated, opinionated choice about how to consume the device.
I mean, even the guys that
can do it. Yeah.
Even the guys that wrote DM cache don't have a tool that sets up DM cache. I mean,
that's true. That's true.
Yeah, and I've never used Ceph Ansible, so I don't take that. Don't take that.
It's like two levels of crazy here. There's the whole craziness of setting up DM cache itself, and then how to adapt that appropriately to your particular Ceph configuration. And I have no qualms with writing white papers and describing what sorts of storage this thing needs, because DM cache is certainly not the only thing that people are going to want to use. But I can make the same argument about SSDs and spinners today. Where should I put my journal? Should I chop my journal up into 4 pieces and put them on an SSD and share that across 4 spinners? Or it's the same story, right? And the problem is,
but I think that's exactly the same kind of solution where we actually, in the long term, do want an automated situation where we just have an installer go and investigate all the disks on the server and say, okay, this disk has this many apps, it can serve as a journal for this many hard drives. Go set that up.
I think the degrees of freedom there are just unmanageable.
I don't think that's the case.
Yeah, I don't think it's that hard.
Josh, I'm willing to entertain the idea that we can do that, but we need to start small. We don't even have any way right now to automatically tell someone how big of a buffer they should use inside Ceph itself. I mean, talking about taking on all of DM cache before we solve our own problems is crazy.
Absolutely, we should write Ceph LVM without DM cache support, and it'll be written in such a way that you can go set up DM cache yourself and just feed it to Ceph LVM and it'll just go, right? But I think that like immediately after that, we have to have a way to make Ceph easier. Like this, I feel like this gets to the heart of why we're getting so much pressure right now from the business, is that Ceph is too hard. Like you have to be a Ceph expert in order to set it up. And at the end of the day, I have a box. It has 24 disks and it has 2 NVMEs. Just carve it up and use it, right? I mean, we want to default to BlueStore. We're going to take those 2 NVMEs. We're going to split them across those disks. We're going to decide how big we want the PVs for the BlueStore wall. That's hard coded. That's a policy decision. And then the rest of the space, we just divide by however many disks that is, divide it into chunks for those disks, and just make that a cache for the data partition. Like it's not that hard to make an opinionated decision.
It is because you have different caching strategies.
Maybe the answer here, though, is that putting Ceph on DM cache isn't the way to make Ceph easier. Maybe it's figuring out what problem we're trying to solve with DM cache and seeing if there's a better way to solve that.
You want it to go fast. You want it to be easy. Yeah. And we can make a thing that does a pretty good job of making go fast and is easy, that is the best of both worlds. And if that's not good enough for you, then you can go, off the beaten path and do it yourself, right? But we can't just say that, there are too many decisions to make, the administrator has to go make them, because they're going to go buy an EMC.
You're conflating DM cache with go fast, though, and I'm not sure that's necessarily true. There are a lot of situations where
absolutely.
If you don't do it right, it's wrong. It's not going to help you. And
so
I worry
Fredo,
that
Alfredo, what are the caching policies that you have to set in DM cache? Like how many knobs are there here?
There's one that is a default, and there's like 2 or 3. Like I don't have them right now at the top of my head to say which ones are, but like there's like 3 different ones. But that's just one thing. I mean, so, I don't want to say no, but I want to say that 2 or 3 things, and I think we'll be going around in circles after that. But let me just say these 2 things. First off, the DM cache team told me like I should like be really think about what we want to accomplish, and like it's having parity in the command line tool and setting up this whole thing for someone else. It's a hard problem. It's not. You mentioned that you have different drives, and like it shouldn't be hard to say, well, you have these things and those things here. It shouldn't be that hard, but I'm thinking it is, and these guys, they do think it is. We can open it up to further discussion, but I'm really concerned about that.
It sounds to me like what they think we're going to do is write a tool that wraps DM cache in a way that is still expressive, where like possibly we have to like pass all the possible combinations of things you can pass into an LVM. Like somehow we have to be able to reinterpret those and feed those all down. Like yes, that's like a Sisyphean silly task. That's totally different than making something that says, I have 2 SSDs and 10 disks, go set it up in the best way. That just makes a single opinionated configuration.
I think that at some point, if we're opinionated and this like we're not going to accept any extra flags and any extra customization. I mean, maybe that's not that horrible.
Yeah, or like one minimal number of knobs, right?
Yeah, but if we're exposing a lot and someone comes and is like, hey, you guys are setting this up like horribly wrong, and I want it like push button and with these other options. Why can you guys make that happen? It's like we don't want to do that.
I don't think we need to make it as the very best config it can be. I think what we need is to come up with a design conservative enough that we know that if you do it, it will be faster. And if they don't have enough hardware to do that, then they can just refuse. But if they do, then we'll set it up a way that works.
Right.
And then, if they have weirder hardware configurations that we don't support or think they know how to do it better than we do because they know how to use DM cache, then that's fine.
So when metadata is really our big problem, at least on NVMe for really fast configurations, where does DM cache fit into that? Like, why does
maybe it doesn't
stuff?
Right?
Yeah, but that's exactly it.
It
right?
might not. But the point is that there should be a tool that says, make use of this SSD and set of hard disks and SSDs in whatever way seems the best given what I have, and it will do that. Maybe it'll just decide that I'm just gonna put the wall there. Maybe it'll decide it's gonna put the database, the DB volume or whatever for BlueStore there. But if you have tons of SSD, then it'll take whatever it's like expects that you're only gonna have this much metadata. It'll just use whatever's left over with DM cache on the other device.
I worry that we're talking about introducing too many layers of things. We already have so many layers of things that try to kind of, in RockCP itself, you can separate out data into different levels, right? So you can put each level on a different device. We've got multiple layers of caches in different places. Now, potentially, we were talking about putting things in DM cache. All of these different layers add the possibility of something going wrong and doing a bad thing somewhere.
Yes. And if it's hard for us, it is 100 times harder for the user. And so we have to do it.
I'm just saying adding more doesn't help, right? Because we already struggled trying to figure this out.
Well, well, okay, that would be an argument for not doing caching at all. But I think it's going to be clear that we have to have caching of some form.
It may be that we don't use DM cache in the vast majority of cases. It's only when the user explicitly requested.
Yeah. Or if they have a ton of SSD and they're like, use it, then we'll use it. I don't know.
No, using DM cache is not hard, by the way. If I don't want to say I want to convey that this is hard. Like I made it work, which is fine. Like, it was pretty straightforward. The hard part is setting it up in a semi-automated way and making those decisions. And,
well, and you say it's not hard, but one of the things it does is have a device for metadata. Is that even relevant? Is that even relevant for a Blue Store OSD? Because is metadata an issue? Metadata on the file system an issue versus metadata in the RocksDB versus metadata in the file?
It's a requirement.
It's the cache metadata. Yeah. I think it has
Speaking of which, have we beat this enough that we can start talking about metadata in Blue Store? That's
you want to move on? Yep.
Yes.
Yeah.
All right. So let's move on to talking about metadata in Blue Store. So this project started with a bout of insomnia at about 2 a.m. last Saturday. Basically, the gist of this is that in Blue Store, when we have a fairly large amount of ONO data per OSD, in this case, it's 512 gigabytes of RBD volume. So actually not that much necessarily, but enough to cause this. We can no longer keep all of the metadata in Blue Store in cache, at least with our default cache values. So we end up doing a lot of reads in RocksDB. And I really quickly this morning grabbed some data during a test. This is 4K random writes on a single NVMe backed OSD with everything on NVMe. So the write-ahead log, the database, and the block partition. And doing 4K random writes to this 512 gigabyte RBD volume, we're seeing that not the vast majority, but the majority of the I/O going to the disk is actually in small reads. There's 18,000 read IOs going to the database partition, and a much smaller number of write IOs, although the total amount of data was higher. Just that the IO size was bigger for those. But you can see on the write-ahead log there that it's actually a high number of IOs going to the write-ahead log, and also a high number of IOs going to the block partition at that particular moment. Overall, looking at the performance impact of this, when all of the metadata for writes in this kind of workload with this kind of size, when you have everything in cache, in this case, dedicating 8 gigabytes of RAM to the OSD so that it can do that, you get about 30,000 write IOPS. But when using the default cache, which is what we have now, I think it's 1 gigabyte if I remember right, we drop down to about 10,000 random write IOPS. It's a pretty big deal. I've also got some compaction stats in here. You can kind of see that the write amp on compaction is not real great, like 3.5. And then also there's a fair amount of reads happening due to compaction. This actually looks much better than it used to. It used to be that the compaction thread in RocksDB was really, really, really busy during random writes, primarily because there's a configuration flag that used to be not enabled to tell RocksDB to do read ahead during compaction. And we now do that. We now set that. So we're doing read ahead. But it used to be that we're just doing tons and tons and tons of little tiny reads, mostly sequential, but through their random read path. So anyway, moving on from this. Okay, what can we do? Well, the nice thing to do would be if we could somehow reduce the amount of metadata that we have. But short of that, maybe there are things that we could do or different solutions that we could look at that would handle reads better. And the one that kind of was looked at a while back, Shinshin had made a key value backend with LMDB. And so I thought, well, maybe it'd be worth looking at this again. So I dug out his old PR and started working on it. I moved it over to CMake from AutoMake, and then also got a couple of things implemented that we needed now, like merge and ARM range keys. So it does compile. The branch I've got linked in there does compile now. It is racy without debugging stuff added in. It crashes pretty quick. But if you throw in lots and lots of debugging in like D-outs in the code, then I can actually get them on to run with it. So there's stuff that still needs to be fixed. There are a lot of caveats with this. It is slow at writes. There's like, it looks like it does 2 fsyncs per transaction. And it doesn't scale with multiple writers. It's only a single writer. So those are some pretty big hits against it. Potentially, there was like a write-ahead log branch floating around out there that the author claimed gave a huge speed up, but it also broke stuff. So I don't know what the status of that was. I was going to see if I could reach out to him and see. So this kind of project, I mean, really, you know, the very specific part is LMDB. Look at it, see if it's worthwhile looking at again. I don't think it quite got a fair shake in the previous PR. There's a lot of stuff there, creating strings and doing memory copying that probably slowed stuff down somewhat. But it does look like it has some legitimate issues. Maybe the bigger topic here, the bigger story though, is you know, we need to figure out how to deal with the metadata workload that we have, because it's big, and the bigger the OSD, the worse it gets. The SanDisk guys were trying to write Zetascale to, or working on like a Zetascale adapter for BlueStore to try to do this better than using RocksDB, but that's kind of out of the picture now. So anyway, that's basically what it is. Anyone have any comments or thoughts?
I think the big question with LMD specifically is just whether the architecture that's not optimized for writes, how that's going to weigh against something that does very well at reads when we're doing lots of metadata reads also. And I don't think there's any way to really know that until we just try it.
Yeah, that was my thought too.
Find out if the recent improvements to add a wall, maybe that'll help. I don't know. We don't really know.
Yeah, it's worth investigating non-LSM structures at least to avoid the application.
Yeah.
Yeah. It's I think you can also, you know, point out that if you look at like any storage system ever, it's usually dominated by metadata performance, right? So if your metadata is slow, then everything is slow. That's sort of a truism, I think, of any Lucidity system, I guess. And it's probably exacerbated in our case just because our workload is so randomized because it's spread across so many different nodes. And so each individual unit of work seems to be small, whereas sort of in a more traditional system, like, you know, you stat the file, you get the inode, and then you write multiple gigabytes. That's a little bit different than serving multiple IOs. Yeah, I'm still hoping that another key value option is going to come along. But
one thing that I've been wondering is whether or not there are any that are targeting NVRAM, NVDIMMs kind of thing.
There are. So last time I synced up with Tushar at Intel, they have, like, you know, a whole plethora of projects going on, but some of them are specifically looking at key value databases on NVMe and on persistent memory. And they, so they're, you know, and that spans from like, let's make RocksDB go fast on NVMe and whatever, and that all the way to, you know, how do we write a key value database with the right semantics that all these distributed systems need, that runs directly on, you know, 3 Crosspoint, using their whatever libraries. So I think there's a reasonable chance that something is going to come along in the next, you know, year or two, but I think right now there isn't really any other good choice.
Yeah.
Maybe LMDB is getting close, but I'm really worried about that writer issue. It's just like, just not designed for, and our workload really is, it's like every IO is a write IO almost. We just have to load metadata in order to service it, to do that right. Yeah.
Yeah.
Yeah, I don't know. The other thing that gives me pause is that the work that they were doing in Zetascale to make it catch up to RocksDB was optimizing the data structures based on what they knew about the write workload. So they wrote specific code to deal with our pglog write pattern, where you have consecutive key values that are getting retired on a sort of a time rotating basis or whatever. And so they wrote like a specific backend for a part of the key space that dealt with that workload specifically. And that was like, that was where they got their performance back. And I'm skeptical that OMDB is going to do that.
Yeah. I mean, one thing we could do there that would at least help a little bit is we don't need that to be in the same database as the rest of it, right?
And we need to be able to commit it atomically. So we need to have atomic transactions. So if we're spanning two databases and need atomicity, then it gets tricky.
Yeah.
You need like rollback and whatever. Yeah.
Okay.
But maybe that's doable. I'm not sure. Anyway, my suggestion would be to make it build, even if it's just on the monitors. Maybe it works well with the monitor workload. I don't know. I think the monitors actually, their IO workload is going to be pretty light now that now that the manager's in place. But it'll, if nothing else, it's just going to tell us more about what. Knowing that something doesn't work tells us more about what we need. So.
Yeah, like I said, once I threw in a lot of debugging lines, I actually was able to run a cluster using it for the monitor, but there's something in there that's not safe. Ooh. But anyway, that's what it is. I don't know. Hopefully we can find something. But related to all of the DM cache discussion, this is what we suffer from right now. This is what we've got to figure out. Sage, you're silent.
Good. Yeah. So I mean, putting all of RocksDB on SSD is sort of like the easy hammer. And
this is all in it. This is all in DME already.
Oh, okay.
Sorry.
Yeah. Yeah, well, DM cache isn't going to help that, right?
No.
What it does do, though, is that when you're talking about a hybrid disk and SSD or disk and NVMe environment, right now Bluestar only puts metadata on the SSD. It doesn't do any data caching. And there are going to be some workloads where we do need caching on disk. So, or there'll also be workloads where the entire OSD is storing key value data because it's RGW indexes or something, in which case, the RocksDB tiering might not be sufficient. I don't know. We'll have to see.
Like the RBDO map will still end up in RocksDB.
But I think, even if you ignore, so even if you say that, going back to DM cache, even if you say that DM cache is not going to work for most workloads, at least with Bluestar, it's not worth the complexity. And if people do want DM cache, they can go set it up by themselves. We still want a tool. We still want to get as close as possible to a workflow where the user can say, I have this many hard disks and this many SSDs. Can set them up in whatever the best way is. And have the tool say, oh, well, you have a ratio of 6 OSDs to SSD, so I'm going to carve each SSD into 6 parts, and I'm going to use this much for the wall and the rest of it for the DB or whatever it is. I think we still want that. Like, I think we should have a Trello card. I think that's like, the equivalent of Ceph disk create, but for like create many, where you just you give it all the devices you have. Like, this is everything in the system. This is everything I want you to use, and it just like goes and creates in. It figures out what n should be, and it does it.
So on the SSD side of that, you need to know whether or not the SSD can do like OD sync writes fast, right? If it has the ability to ignore the flushes.
Yeah, I mean, maybe if that, I mean, that's obviously has a big impact on performance, but is it going to have an impact on how we use the SSD? Like, are we like not gonna put our journal on the SSD because it has slow OD sync?
Maybe. I mean, some of the people on the list used to say that it was worse, right? With certain SSDs, if you try to do that.
Then just using a hard disk. Like, you're still going to put it on, even the slowest SSD is going to be faster than a hard disk.
Well, it seems like that's exactly the kind of thing this tool should do, which should go and like run a benchmark on these SSDs and figure out how many OSDs they can support.
That too.
Yeah. I mean, maybe maybe it'll work.
Maybe it'll say, I don't recommend this. -- force. Do it anyway.
Yeah.
Right. Yeah. Exactly.
And I might go a step further and even say just give it a node, and it goes and looks at which disks are used. And
yes. Exactly. Yeah. I mean, yes. Right. Exactly. That would be the next step.
Thank you for killing my Postgres database.
Yeah. Yeah, I mean, I think one of the things that Ceph Disk tried to do that I think was a nice idea, but didn't end up being that useful, was that for every OSD, it has this prepare and create, or prepare and activate distinction, so that you could have like a stack of blank disks that are labeled as blank, and it would go and it would do it. But the way Ceph Disk did it, like did a little bit too much. It like already partitioned them the way that they should be, with the marking them as like consumable by Ceph, and then they went and got activated within a particular cluster. I think just having a convention that just says like, this is a way to label a blank disk as blank and allowed to be consumed by Ceph would be sufficient. Maybe that's just like, creating one big PV with the label Ceph-blank or something. I don't know, whatever it is, like, just so there's a way to just like have to mark everything that's usable, and then have all the other tools know that they're free to consume them, that they don't have their Postgres database on them. Okay, well, we're like an hour over.
Yeah.
Anything else? Who wants to? We're ready for lunch. All right. Thank you, everyone.
Thanks, everybody. And if you've made it through this recording, thanks for sticking with us. Otherwise, we'll see you in a month.
All right. See you guys.
Everybody.